Hello everyone, welcome to another video of Everyday E-Learning. In today's video, we are going to learn how to convert a decimal number to binary, octal and hexadecimal system number. So let us start. We have the following example first, which is we have to convert 18.625 from decimal format to binary format. So let us start. For this process, we'll have to convert the whole part and fraction part separately. So we can do it the following way. Let us divide 18 by 2, as 2 is the base of the binary system, and we get the quotient part and the remainder part. So if we divide 18 by 2, we get 9 as quotient and 0 remainder. And then again we take the quotient and divide it by the base. So for this we have 4 as quotient and we have remainder 1. And we do the same again with this one. 4 divided 2, we have 2 and remainder is 0. And we have again 2 divided by 2, we have quotient 1 and remainder 0. So we'll stop here when we have 1, and we will start from the last quotient, move to the right side and then up. So if we convert 18 to binary, we will get 1 0 0 1 0. We move from here to here and then up. This is for 18. And now we have this part left. So we take 0.625 and we'll have to multiply this time instead of the division that we did in the previous stage. So we multiply with the base 2 and we again have two parts, the real part and the fraction part. So if we multiply 0.625 with 2, we get 1.25. So we write it here. And again, we take the fraction part and multiply it with the base. So 0.25 into 2, we get 0 and the fraction part 0.50. And we again take the fraction part 0.50 and multiply with it 2, and we get here 1 and 0.00 as the fraction part. So we end up here when we don't have any more fraction part, and for this we go the opposite order. We come down from here to here to write it down in binary format. So if we convert 0.625 into binary, we'll get 0.101. So if we write them together, we have 18.625, which is in decimal, to we get 10010.101 in binary format. Now we'll take another example of the same type, but that has a different ending. So let's see. We'll move down, take the second example, 172.878 decimal to binary. Now if you convert this portion, it is the same as the previous one. So let us see. 172 divided by 2, we have here the quotient and here the remainder. So if we divide 172 by 2, we get 86 with no remainder. And again we divide 86 by 2, so we have 43 quotient and remainder 0. And we again divide 43 by 2, so we get 21 with 1 as remainder. And we again divide 21 with 2, and we have 10 with remainder 1. And we continue it again so we have no remainder here. 5 divided by 2 is 2 with 1 remainder, and 2 divided by 2 is quotient 1 and no remainder. So like the previous one, we'll move from here, sorry for that, we'll move from here to here up, so we get 1 0 1 0 1 1 0 0 for the whole part. And now we convert the fraction part. We have 0.878 and we multiply with base, so we'll have the real part or the whole part and the fraction part. So 0.878 into 2, we get 1.756, and then we again take the fraction part, 0.756 into 2, so we have 1.512. We again take the fraction part, 0.512, and multiply with 2, and we end up with 1.024, and we try again into 2, and we have 0.04. okay, I'm sorry, that will be 0.48. So it will continue to a certain manner, so we'll not go beyond 4 places. So we'll just take this 4 and write our result, and that will be 1110. So if we convert this whole number 172.878 from decimal to binary, we'll get 10101100.1110. Now in the next one, we'll see how to convert from decimal to octal system. So we'll have the third one as 20.62625. Okay, I did not want that. 625 to octal. Now we will go with the same way, so we'll take the whole part first. We have 2020 and divide it with the base of octal number system, that is 8. Now we have again the quotient part and the remainder part. So if we divide 2020 by 8, we get 252 with no remainder. We again take 252 and divide it by 8, and we have 31. I'm sorry, we'll have a remainder here, that is 4. And again, if we divide 252 by 8, we have quotient 31 and remainder is 4. And then we take 31 divided by 8 and we get quotient 3 and remainder 7. Now we end up here as we have this number smaller than the base, and then the same way we move up like this. So if we convert 2020, we get 3744 in the octal systems. Now we have the fraction part, which is 0.65625, and we multiply it with the base of octal, and we have the real part and the fraction part. So if we multiply this number with 8, we get 5 in the real part and 0.25 as fraction. Now we again take the fraction part, 0.25, and multiply it with 8, and we have 2, and here we get 0.00. So we do like this same again, come down, and then we have 0.65625 converted to octal, which is 52. So if we just write down the whole number, 2020.65625, which is in decimal to binary, we have 3744 0.52 in octal systems. Now we'll move on to the last example, in which we will learn how to convert from decimal to hexadecimal. So we are given 5050 in decimal systems, and we have to convert that to hexadecimal systems. So we'll follow the same way. 5050 into, we'll do division for the whole part, division 16, and we have here again the quotient and the remainder part. So we get 315 as quotient, and we get remainder 10. We again take the quotient 315 and divide it with 16. We have 19 here, and remainder is 11, and we take 19 here and divide it by 16, and we have quotient 1 and remainder 3. So we'll stop here because this number is smaller than the base of hexadecimal number system, and then we move like this again. So if we convert 5050, we have 1 3, and in hexadecimal system we denote 11 as B. Okay, let me take a different color. 11 as B and 10 as A. So we'll write here 1 3 B A. So we get 5050 from decimal to, okay, why would that come? From decimal to 1 3 B A in hexadecimal format. So I hope you understood how to do the conversions. If you have any queries or questions, feel free to write down below. Thank you for watching this video.